All right, everybody. First video for 11.4 and 11.5. These sections are both about circles. One is about area of circles, and one is about circumference of circles. But also not just of the whole circle, but parts of the circle as well. And what I'm going to have you do for this section is I'm going to have you do first an investigation, sort of seeing how this all works. And I'll work through the first part of the investigation with you here in this video for both the area part and the circumference part. That's going to be worth part of your grade. And then second part is going to be just a few more notes on it, just so you get a little bit more exposure to it, which will then be followed by an assignment as usual. So let's get right into it with a little bit of vocabulary. This is going to be important vocabulary for what we're doing here. All right. So a little bit of the vocabulary that we have, starting with area of a circle. So just as a short recap, I know we've seen this recently. Here's a circle. Remember, if we have a segment going from the center to the edge of the circle, that is something that we call the radius. And I told you that sometimes it's used and represented by the letter R. This is going to be one of those times. The area of a circle is kind of like what it is for everything else. The area of the circle is basically how much space is taken up on the interior of a circle, that whole space in there. The formula for area of a circle is going to be pi. Many calculators have a button for pi, r squared. If your calculator does not have a pi button, you are usually pretty safe using 3.14 for pi. So you'll do pi times the radius squared. That'll be the area. Remember, it's going to have units squared as part of it because it is, in fact, an area. Circumference of a circle is a little bit different. The circumference of the circle is kind of like the perimeter of the circle, what the distance is going around the circle. That formula is 2 times pi times r. So you'll just do 2, then you'll do either multiply by pi if your calculator has a pi button, or by 3.14, and then you'll multiply by radius. And that'll give you the distance around the circle, going around the edge of it. Those units will just be plain old length, centimeters or yards or feet, because it is, in fact, a length. So now we have these two new words, sector and arc length. I'm going to draw a new circle, just so it's a little cleaner. A sector is basically what we get when we have a central angle and we cut off part of the circle. A sector is going to be the area of part of a circle. And we'll talk about exactly how to calculate that. I mean, that's part of what this investigation is going to be about. And similarly, arc length is, well, it's really what it sounds like. Length of part of the circle. So if we have the sector over here, arc length could just be this part of the circumference, the part of the circumference that is cut off by that arc. Central angle, I won't write down the definition because you have that already, but a central angle, again, is just an angle that starts its vertex at the center of a circle, kind of like that picture. So, like I told you, I am going to go through this first example here with you, and then I will leave the other ones for you to do. I'll give a bit of a pause, and then I'll start out one of the arc length examples with you as well. Okay, so the calculator I currently have with me has 3.14. It does not have pi as a button. So what that means is I'm going to need to use 3.14. If you use the pi button, your answers are usually going to be a little bit bigger than mine are, which is fine. All right, so in this first circle, we have that the radius, we can see the radius here is 4. If we had been given the diameter, we would just divide it by 2, and we would then have the radius. So the area of the circle then is, remember, pi r squared. I'm going to be using 3.14 as pi. So we're going to have pi times 4 squared. So if I type in 3.14 times, and then I'll do 4 squared, I get 50.24. We don't have units here, so I'm not going to use them. Now, we have a right angle, which is 90 degrees. If we're trying to think of a fraction that is shaded, well, looking at the picture, I can see that it's 1/4, right? It's 1/4 of the circle that's shaded. And it's not always going to be that easy to tell. What if it were a weird angle? What if it were 110 degrees? So don't just do it based on looks, unless you are absolutely sure that's what's happening. But I want to give you another way to look at it for those examples where it's not going to be so easy. Because it is 90 degrees, and this is how we can explain this fraction. It's 90 degrees out of how many altogether? It's 90 out of 360 degrees, right? 360 degrees in a circle. So if we were to simplify that, we could divide both by 10, we would get 9 over 36. We can divide both of those by 9, and we end up getting 1/4. So the reason it is 1/4 of the circle is because it's 90 degrees out of 360. Well, if it's 1/4 of the circle, that means that if I take the area of the circle, which we calculated in the first step, I should be able to take 1/4 of that and get the area of the shaded region. And that's what I'm going to do. So to find the area of this shaded region, I'm going to do 1/4 times 50.24, and we will see what that ends up being. So you end up getting 12.56 for that. And that's how you would approach that one. So I will leave the other area examples for you. I'm going to leave a little bit of a pause in the video. You have a choice to either continue watching this right now, or if you want to try out the other area ones, go for it, and then continue watching the video when you get to the part on the back, which deals with arc length. So either just keep going right now and flip to the back, or try these other area parts out, and then continue the video in a little while. All right, so we're here with the arc length part, and this is going to work pretty similarly to how the other side worked. You can see the setup is quite similar. Well, here we have a circle. We're told the diameter is 14. If the diameter is 14, that means that the radius is half of that, which is 7. So, remember, circumference is 2 pi r. Again, I'm going to use 3.14 for pi. So I'm going to have 2 times 3.14 times 7 in this case, which gives me 43.96. Again, no units. This time, we have a semicircle going on here. So that is 180 degrees. You can see also, looking at it, well, let's just go from there. 180 degrees over 360, that's half of the circle, which means that's the fraction. I kind of did just explain it here, and you may end up doing that that way. So for the arc length, just like before, I should be able to take what I had, multiply by a half. So we'll have 1/2 times 43.96, which is then 21.98, and that would be the arc length. So very similar process to what we did with sectors, but using arc length instead of, we're dealing with circumference instead of area formula. So try to fill out the rest of the sheet, and once you do that, I would say you're ready for the formal notes. You may want to check with me or someone else to see if you are coming to similar conclusions about how these work before you start. But make sure that you then show this to me so that you can get credit for the work that you've done. Thanks for watching, and good luck.